I'm guessing the directions were verify the identity. Am I correct? Yeah. Well, is that guideline of messing with the side with more stuff on it going to be what you want to go by here? No, because you see the cosine of 4 times x, right? And you know a trick for playing with that. Now, you could write it as cosine of 2x plus 2x, but that wouldn't be the quickest way since really you want to apply one of your double angle formulas here. So I'm going to start with the left-hand side, cosine of 4x. So right down the side you're starting work one step to the right. I'm going to think of cosine of 4x as cosine of a double angle, which would be 2 times 2x, right? So I'll have to introduce an extra set of brackets here. Isn't that true? You may not know exactly where I'm going yet, but do you believe that? Yeah? Cosine of 2 times 2x. So we have an identity for a double angle formula for cosine, right? We've got a couple of them. The first one I introduced to you, cosine of 2 theta is equal, this is scratch work here by the way. Cosine of 2 theta is cosine squared theta minus sine squared theta. Remember that one? I don't think we want to use that one because I peek at the right-hand side of the original identity and it has all powers of cosine in it, right? So is there a variation on this right-hand side with all powers of cosine? Yeah, and you don't even have to memorize it if you just remember sine squared theta is equal to what in terms of cosine squared? And then remember you distribute the minus there. And what's the identity become then? You end up having 2 cosine squareds, right? Because you distribute this minus, this will become a plus. 2 cosine squared theta, and then this 1 right here becomes a minus because you're distributing the minus. So this is the one we're going to use. Does that make sense? You're all sure, anything at this point. He's been talking for over an hour. Okay. All right, so what's acting like theta here in the statement of the identity? What's acting like theta? It's 2x. That's the thing you're doubling, right? So when you plug it in, here you've got to replace theta with 2x. Does everybody see that? Okay. So you get 2 cosine squared 2x, I'm going to put that in parentheses, minus 1. Everybody with me? All right, now here's the part where things could go a little awry, let's say. And we'll have to do more scratch work. So really, when you see cosine squared of 2x, it's really cosine of 2x, the whole thing squared. So all I did was rewrite it symbolically. This step you don't need to include. But does everybody agree that's the same thing? Oh, we've got a double angle, cosine of 2x. Let's apply this same formula once again. Now, this time, what's acting like theta? Well, no, well, yeah, I misled you there. I didn't mean to mislead you. So let me, just x, right? So we're applying directly the double angle formula where except theta equals x. Everybody believe that? Okay. So I don't think we need any more scratch work than we already have then. So we get 2 times, okay, we've got a set of brackets, squared and then a minus 1, right? And we're going to replace this guy in here with the double angle formula. Again, the one only involving powers of cosine. So 2 cosine squared x instead of theta minus 1. Another reason why I knew I wanted to use the double angle formula is the right-hand side involved an even number times x, right? The cosine of an even number times x. The right-hand side just involved inputs of x. So I knew I had to reduce those inputs of x, right, to a single x. So the double angle formula is good at doing that. Everybody with me? Then guess what we have to do with this nice quantity here? What do we have to do? We're going to expand it, right? And then when you expand it and combine like terms and do a little more work, you're going to get that. Let's see if we can knock that out. So when we expand it, okay, I'm going to switch to parentheses. We square the a plus b quantity squared equals a squared. Actually, it's a minus. So a minus b quantity squared equals a squared minus 2ab plus b squared. Remember that? That formula says we square the first guy. The first guy is 2 cosine squared x. What do you get if you square that? Oh, except you have to square the 2. So 4 cosine to the 4th x. Yeah? Okay, minus 2ab, what's that going to be? Minus, so you multiply this guy, this whole guy right here times this guy and double it, right? So minus 4 cosine squared x. Everybody buy that? So that's minus 2ab plus b squared. The last guy squared is plus 1. Okay, now be careful. We still have this x. No, we don't have that exponent of 2. I'm sorry, I meant to say we still have the minus 1 out here. Everybody with me? Now let's multiply things out, combine like terms, and see if we get the right side. So if you distribute this 2, what do we get? 8 cosine 4th x minus 8 cosine squared x plus 2 minus 1, just one like term to combine, I guess. 8 cosine to the 4th x minus 8 cosine squared x plus 1. Everybody see that? Now we better check, right? I don't remember. Does that equal the right side? Well, okay, yeah, it's written differently, but it's the same thing, right? Same thing. They're writing it in the order 1 minus 8 cosine squared x plus 8 cosine to the 4th x. That's fine. I wouldn't even reorder it. That's done.
So in this problem, it's easier.
Okay, that's a fun problem. I don't care who you are, right?